Hello everybody, I'm Dominic Vidal and welcome to Engineered to Drive. This channel is all about building a track-focused car that can still be driven on the roads. To kick things off, let me introduce myself and my Audi S4, my personal project and the heart of this journey. Let's get started. I'm a mechanical engineering student with a deep passion for motorsports. My love for cars and engineering stems from both of my grandparents. On my dad's side, my grandfather was a mechanical engineer who worked for Chrysler in Panama during the 70s. On my mom's side, my grandfather was an adrenaline junkie who could not resist the smell of gas. I bought my 2010 Audi S4 in February of 2024 with 133,000 miles. Before that, I owned a B7 A4 with about 80,000 miles on the clock. Sadly, that A4 met its ultimate end in December of 2023 after being totaled in the Walmart parking lot. When I purchased my S4, I thought I was getting a well-maintained car with a few tasteful modifications. However, it quickly became evident that it had a long list of deferred maintenance. On the drive home from the dealership, I got a low coolant light, so I stopped to top it off and limp it home. After some troubleshooting, I discovered that oil and coolant were mixing, and I found out that the culprit was a bad PCV valve, a well-known failure point in this platform. While addressing this issue, I also decided to replace the water pump and thermostat, as those are also commonly bad and there's a lot of overlapping labor when doing these jobs. Not long after, all cylinders on bank 2 started misfiring under hard acceleration. I discovered that a clogged VVT solenoid caused by the coolant oil milkshake from the bad PCV valve was the issue. With the car's history mostly unknown and early DSG transmissions prone to failure, I decided to do a DSG service for peace of mind. Soon after, I found out that the DSG fluid had actually been serviced less than 10,000 miles ago. This car made it through the rest of the semester and into the summer without issues. Sometime around August, I noticed that the oil smelled a little bit like fuel, which is usually caused by a bad seal in the high-pressure fuel pump. I replaced the seal and upgraded the piston with 034 Motorsports upgraded high-pressure fuel pump piston. Doing so allowed me to run an E40 mixture, which gave me a few extra horsepower. The next issue came during a drive back from Chicago's airport, a place that tends to bring me bad luck. A piece of scrap metal on the road destroyed one of my tires, forcing me to drive over 50 miles on the spare donut. Since I purchased the vehicle, I had been hearing a popping sound coming from the suspension, usually caused by bad bushings in the control arms. With the need for new tires, I decided it was a perfect time to upgrade to 034 Motorsports full front suspension kit. This quickly turned into a nightmare with the infamous pinch bolt. I tried everything from heat to an air hammer to drilling it out. I eventually had to buy 2 new knuckles to assemble the entire thing. Thanks to the SAE club at my university, I was able to sign up to a NASA HPD event in Audubon Country Club in Joliet, Illinois. This was exciting, however, it meant that I had to do a little bit more work on my car to get it ready for the track. My biggest concern was with the front brakes. The stock brakes perform well on the street, but many experience brake fade on the track regardless of compound. To address this, I upgraded to the 4M Q7 calipers. These brakes perform better for 2 main reasons: improved heat dissipation and more even pad application. The larger rotor and pad size alongside the aluminum calipers provide for better heat management and better thermal conductivity, ensuring more consistent performance on track. The upgraded brakes gave me the confidence to push my braking zones harder, and I made it through the weekend without any issues. As I mentioned earlier, driving to Chicago tends to bring me bad luck. On the drive back from the track, I ran over a pothole and cracked one of my wheels. I had it repaired at a local machine shop, but the repair now makes the wheel more susceptible to cracking in the future. 2 weeks after the repair, I took my car on another HPD session at the National Corvette Museum, where I was promoted to HPD 2. However, it wasn't without any issues. During a few of my sessions, I got a gearbox malfunction light and it threw the car into neutral, forcing me to pull over on the side of the track. This is a very scary experience with cars flying past you at over 100 miles an hour. After a little bit of research and confirmation with the codes, I found that the gear position sensor had gone bad on the transmission. This is a very common issue with the early model DL501 DSGs, requiring transmission removal and disassembly, alongside pricey components like the wiring harness and the sensor itself costing $500 each. I'm starting by draining the DSG fluid and removing the exhaust and the drive shaft. In most cars, removing the exhaust isn't too bad, but in this 14-year-old German gem, the downpipes have nuts in the most awkward spots, making it nearly impossible to get them out. To make matters worse, the previous owner welded the entire exhaust system from front to back. Our plan was simple: slide a big table under the car and lift it without the transmission.
Spoiler alert, this turned out incredibly sketchy, and you'll see why. Once we had everything underneath disconnected, it was time for the top bell housing bolts. Getting those out required some seriously creative body positionings.
Just want to give a progress video on how we got one of the bell housing bolts off. Standing way the back there. And the fastener is all the way over yonder. All but one bolt on the bell housing is left. We're just gonna ideally drop the transmission down on the table, undo the last few fasteners, undo the transmount, and then lift the car without a transmission in it.
With the last flywheel bolts removed, the transmission was ready to come out. It's at this point we realized how sketchy our cinder block plan really was.
We have to go back just a little more. We haven't quite slid the flywheel yet. Alright. And by just a little more, I mean like less than half an inch.
Okay. Okay, stop.
After a quick wardrobe change, we got to work fixing our mess. The way the transmission was sitting meant that if we tried lifting the car any higher, this beautiful DSG would have been nothing more than an expensive paperweight. Not exactly what we had in mind. This meant that we had to rethink our approach. We tried a pole jack at first, but it quickly became clear the transmission might tip forward. We needed something wider to catch it as it came down, so we swapped it for a floor jack. This made all the difference as we were finally able to level out the transmission and push forward with the job. With the transmission finally at the right angle, we cleared the flywheel. From there, we carefully lifted the car, making sure everything was stable. Removing the transmission took longer than expected, but at least we were back on track now. With the transmission out of the way, the cats came out much easier. Well, except for that top nut. To get those nuts out, we had to use every swivel we had in the toolbox. But overall, the cats were in pretty good condition. Next, I moved on to disassembling the front of the transmission. I began by removing the front axle, the clutch cover, and the front diff. With all that finally out of the way, I was finally able to see the clutch basket. This part is usually pretty straightforward if you have the special tool, but since I don't have that, I opted to use a bearing splitter and a slide hammer. After some effort, the front of the transmission was finally disassembled and we decided to call it a day.
Y'all gotta see this. I got these two bolts that actually hold the engine mount to the subframe on the back side. Those are the next thing to remove so we can keep getting these out of here. Another thing, I removed this guy, a 16mm nut goes to this stud that holds your connector, and it's got a little backing plate for these big wires here. Just one more thing that might be in your way. We pulled them big bolts out. These guys, they are triple square on the inside, 18mm hex head on the outside. And so now the only thing we got left are those two 8mm triple squares right there. And this should be pretty well ready to come out. Other side goes, I still have to continue to lower this subframe. I also have a connector up back in there. That's about where we're at. After a lot of convincing, we finally got it to the point where we can remove it. We're gonna gently attempt to slide them out the back because the transmission is not in this car. We've got both motor mounts out. They're both junk. I mean, that one's ripped in half and this one's got a big old gash in it. To do that, we've had to completely remove all the subframe bolts. We're hanging down, our motor's tipped. The majority of our problem was this stripped out bolt right there. We got all the subframe bolts down and we could get access out of the back here. We've got the driver's side motor mount in. That was an adventure. I'm working on the passenger side right now. I'm gonna tighten this thing down, button it up, and then the next step is start trying to get this engine to go back on this subframe and then put this subframe back on the frame.
With the motor mounts installed and the engine leveled back up, the transmission was ready to go back in the car, and we were all set to start the car for the first time.
We wrapped up putting the car back together and hurried back to school as we had finals the following day. The car felt great. It was running smooth, and I felt a little bit of added throttle response with the test pipe file. I parked the car for winter break and went home to see my family. I planned to replace the drive shaft on my car at some point when I got back, as the CV boots were torn and some of the grease was coming out. I did not plan to do it right away though, but life had different plans for me. When we dropped the transmission out of the car, we couldn't manage to get the drive shaft off of the rear diff, so we decided to just leave it hanging off of the already torn center support bearing. At some point during this work, we decided to remove the drive shaft as it was in the way. When doing so, the cover for the rear ball bearings came off, leaving the ball bearings in the differential. I struggled to get this cover and the bearings to line up, but we finally got it. Or so we thought. I had installed the test pipe file. I had not yet tried the advanced launch control feature, so I decided to give it a shot. Doing so, I ended up launching the ball bearings instead of the car. Bearings must have not been seated correctly, and when I tried to launch my car, the bearings shot out through the cover and even managed to cave in the heads of the bolt. I got the car towed back to my girlfriend's place and left it there for about a week or two while I waited for the drive shaft to come in. When the part came in, the car was still not able to move under its own power, so I decided to fix it right there on the side of her house in the winter with snow outside. That was a great experience. That wraps up the story of me and my S4. Every twist and turn, whether it was a misfiring cylinder, a stubborn pinch bolt, or a drive shaft drama, reminds me that engineering isn't about perfection. It's about learning from every setback and pushing forward. I'm grateful for the challenges because they fuel my passion to refine this beast for both the track and the street. Thanks for riding along with me on Engineered to Drive. I'm Dominic Vidal, and I'll see you on the next episode. Stay safe, keep pushing the limits, and remember, every problem is just an opportunity to engineer a better solution. See you in the next one, guys.